Hi again. A couple examples back, we had a look at a Hardy-Weinberg problem involving rhesus factor, and now it is back. They, we know that the rhesus factor is governed by a dominant allele, which means yes, you do have rhesus factor, and a recessive little r allele, which means no rhesus factor. And we know that we can model this using the Hardy-Weinberg formula. And its little sibling, p plus q equals 1. Okay, so they're telling us, the catch with this one is they give us the wrong information to start. They say 85% of the population of Alberta has Rh positive blood. Where's that 85% go in the formula? The answer is that's not a fair question. We don't know because p squared represents the people who are big R, big R. They have rhesus factor. 2pq represents the people who are big R, little r. They also have rhesus factors. So these two groups together are 85% of the population, and that makes this kind of hopeless. The good news is, if 85% of people do have rhesus factor, then 15% of people don't, and we know those people all fall into this one group. So that's where we want to start. That's where we can get a grip on this thing. These people are little r, and they are 15% of the province. That lets us write q squared equals 0.15. And now we have something we can solve. If we tried to solve this, we'd be writing p squared plus 2pq equals 0.85, and that would give you a headache real quick. It's got two variables, which is bad news. It's got p occurring in two different places, which is a nuisance. Mathematically very slippery, but this we can definitely handle. So we want to get the square off there so we can have just q. A square root will do that for us, because squares and square roots cancel each other out. So on the left side, with those both gone, all we have is q. On the right, we have the square root of 0.15, which I do not know, but my calculator can help me. It's 0.387298. Okay, that's probably plenty of decimal places. And we know that p and q have to add up to 1, so if you want to know what p is, start with 1 and subtract off q. 1 minus 0.387298 gives 0.612702. If you want, you can add these together real quick and confirm they do add up to 1. That's a good thing to do if you have time. And now that we have p and q, we are probably set to find anything they want. What do they want anyway? What percentage of Albertans would you expect to be heterozygous for this trait, meaning this group, big R, little r? Well, we can find them. The formula tells us. It tells us if you want the big R, little r group, you have to do 2 times p times q. 2 times p is 0.612702. Q is 0.387298. And that comes out to, pause for calculator punching, times 0.387298. I get 0.4745. 474.597, I guess. I've been giving everything else in this one to 6 decimal places, so let's stay with that. 474.597. That would be okay as a decimal answer, but they've asked for nearest whole percent. So if we multiply this by 100%, we get 47.4597%. And if we round that to the nearest whole number, we'll go, okay, 47. Are we rounding up? No, 4 is not big enough. we're staying at 47. If this had been 5 or higher, we would round up to 48%, but today it is 47%.